Hi Year 12. This is the start of a new topic. It's our 7th topic for Year 12 and it's called sequences and series. I think you're going to prefer this topic to our last one. It's a little bit easier. It's very algebraic, but there are some formulas that you need to work on with this topic. Also, it aligns a little bit with our Extension 1 topic. So if you're in the Extension 1 Year 11 class, it lines up nicely with that as well. Okay, so here's your booklet. You should have that by now. And we're going to have a look at today 1A and 1B, because 1A we're going to get through fairly fast. And 1A looks at sequences and how to specify them. This actually relates to Chapter 1 in our Year 12 textbook. So if that helps you understand that it's the first one, it's a fairly easy one. So a sequence is formed by arranging integers in some order that continues in a regular fashion. So I guess the thing there is a regular fashion. The series may be infinite, in that it continues forever. And this is indicated by writing the last term in the sequence as 3 dots, which are called ellipses. So we often write that, and I think we're used to seeing that before in maths. So here's an example of a sequence, and we often call them series or progressions. So we're starting at number 1, and we would call that term 1, and we write that as T1. And the little bottom value here is a little subset, and that is going to be written how that is in the textbooks as well. So we can see that we're going up in a regular fashion by 2s, and each term would be term 2, term 3, term 4, and we've got an example here of term 9 or T9 is 17. This is an infinite series that increases by 2 each term, so we could continue that on forever. The 3 dots can also be used to specify that some terms that are in the sequence have been omitted. And this is commonly done when the series or sequence is finite to save space and time by writing out all the terms. It would take a lot to write out this sequence or series below. So we've basically said, well, the pattern goes up in 2s. There's a whole lot of numbers between 7 and 99, but 99 is the last term, and the 3 dots or ellipses shows us that there's missing numbers. Okay, so specifying a sequence. There are different ways to specify a sequence. We write out the first few terms until the pattern is clear, and then we can do our 3 dots. We could give a formula for the nth term, or provide instructions on how to proceed from the start of the sequence. Now, these 3 things you're actually commonly looked at before in maths. So you might have seen patterns or sequences in primary school or Year 7 or Year 8. We're just going to formalise what those are to start with today. Formulas are usually written for Tn, and this is the value of the nth term. So we're going to have a look at that below in the examples. So example 1 says to write down the first 5 terms of the sequence given by the formula Tn is 7n minus 3. So to work out each of those 5 terms in that sequence, all you're doing is popping in for the letter n, 1 and then 2 and then 3 and then 4 and then 5. So what you'll end up with is, okay, these terms here, term 1 to term 5, and if you were to write them like we wrote up above with commas between them, like over here, I could write that. 4, 11, 18, 25, 32, dot, dot, dot. And there's 4 dots there. Okay, so fairly simple. Okay, so the second one, B. Describe how each term, t to the n, can be obtained by the previous term, t to the n minus 1. So let's have a look at it. So let's see how we can get term 2. We would get that by getting our previous term, 18, and subtracting 7. So that's basically saying, okay, term 3, take away 7 is equal to term 2. So we would then get our term n minus 1 by going term n minus 7. Or, if you wanted to rearrange that, you could think of it as that term n is going to be term n minus 1 plus 7, which is basically really what that's saying, isn't it? But there are your 2 options. One, you're adding 7, one, you're minusing 7. So let's have a look at 2a, saying that find the first 5 terms of the sequence, given that term 1 is 14, and that term n is the term before it, term n minus 1, plus 10. So using that information, we could then say that the second term, term 2, would be equal to that first term plus 10, which is 14 plus 10, which is 24. So we're going to add 10 on each time. So let's just write it out like this. We've got 14, we've got 24. We're going to add more. 34, 44, and 54. And they're our first 5 terms. Write down the value for the nth term, t to the n. So the rule that we use for t to the n, we want to be able to use for any position in our formula based on n. So you're just going to have a look and try and make up a formula. So I can see that my first term gives me 14, so that would be something on the lines of 10 times that position of n, which is 1, plus 4. That would work. Let's see if that works for the second one. Term 2, where n is 2. 2 times 10 is 20, plus 4 is 24. So that's going to work consistently along there. So that formula will work for that one. Okay, number 3. Find whether 300 and 400 are terms of this sequence. If they're terms of this sequence, then we would have a whole number n, and it has to be a whole number, which that sequence would work for. So let's test 300. So then we would have that 7n plus 20 would be equal to 300. So 7n would be equal to 280. So n would be 280 divided by 7. 280 divided by 7 is 40. So yes, 300 is a term. Term 40 is our 300 value there, or sorry, is what the value is for that 40th term. And let's test 400. Same way, 7n plus 20 is 400. 7n is 380. N is equal to 380 divided by 7. N is 54.285, which is not a whole number. So we're going to say that 400 is not a term. Okay. Let's have a look at the next one. Next question down is how many negative terms there are in this sequence here. So let's have a look at the language for that. So we want negative terms. So negative means we're less than 0. So we want to find terms for which 12n minus 100 is less than 0. Not equal to 0 because it says negative. So let's look at 12n minus 100 less than 0. That means 12n is going to be less than adding 100 to both sides, 100. So, oops, I'll left my n out there. So we're going to say, dividing by 12, the n is going to be less than 100 over 12. So dividing that, we get n is less than 8.333 repeater, or less than 8 1/3. So we want a value that is less than 8 1/3, and that's going to be n is equal to 8. So there are 8 negative terms in this sequence.